Hello everyone, I am Soumyashree Senapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So, in this class, we will solve shear force and bending moment. We will find out shear force and bending moment in case of simply supported beam while application of UDL is there. So, to calculate the shear force and bending moment, we just need to draw the perfect diagram of it. As we are having one beam, let's first draw the beam. And we know that the beam is simply supported. Okay. So, we know the structure of simply supported beam. What more in question? Simply supported beam with UDL. So, UDL is nothing but your uniformly distributed load. So, uniformly distributed load, that means the load at this point, the load at this point and this point will be same. So, UDL will be W kilonewton per meter. Okay. And take the whole length as L. Okay. Now we have draw the whole structure of the beam. Okay. Now we need to find out how to find out shear force and bending moment. So if we just follow the procedure, we will find out. Okay. So first we need to find out reaction forces. Let's name it as A here and B here. At midpoint it will be C. Okay. So the reaction forces will be nothing but here RA and RB. RA here at point B, reaction force will be RB. Okay. So if we just notice, we know W kilonewton is application of load and applying where? Total length at total length. So the total load will be WL, we can write. Okay. Because W kilonewton is applying whole part of the beam. Okay. Next, how to find out the reaction forces? So to first, let's take movement at point B. We know to find out movement, we know the what? Force into perpendicular distance. So we have the forces here RA and another force is point here. Okay. So we just need to calculate at point B, that is RA into L and minus WL into L by 2. Okay. As we know, this point is nothing but your L by 2. Right. So it will be RA into L minus WL into L by 2 is equal to 0. So we can write RA into L will be WL square by 2 and let's do this, and here RA is going to be your WL by 2. Similarly, if we find out movement at point A, what are the forces? One force is your reaction force, that is RB, and another force is nothing but your WL. Okay. So, the very similar forces, that is RB into L and minus WL into what? L by 2, that is 0. And RB is going to be your what? WL by 2. Okay. Now we have found out the reaction forces at point A and B. Here it will be your WL by 2 and here also WL by 2. Now let's go for the calculation of shear force. We need to remember that always shear force can be calculated, shear force or bending moment, it can be calculated only from left hand side of the section or from right hand of the section. Okay. As per the comfortableness, you can calculate from right or left hand side. So, as we need to draw the shear force and bending moment diagram, let's do it from here. Okay. And whenever we are calculating shear force and bending moment, we need to just draw one section. Let's cut this section from here and it will be XX. Okay. So, let these to this distance is nothing but your X. Right? So, whenever you can see if this distance is X, we can put the at midspan WX. There will be no issue. Okay. If from A to point X is distance X, so in this section we are having X by 2 and here we are having X by 2. No issue. So, now let's calculate shear force. So, what we will get? RA into X, sorry, RA into what? WX. Sorry. We are having RA. It will be your what? Shear force at X. RA minus WX. Okay. At section XX. Okay. We know what is the value of RA. Let's put it. So, it will be WL by 2 minus WX. At section XX, the shear force is going to be what? WL by 2 minus WX. So, if we need to find out at point A, so what we will do? We just need to change the value of X. You can see at point A, the distance is 0. So, here in case of X, we need to put what? WL by 2 minus W into 0. So, shear force at point A will be what? WL by 2. Right? In case of point C, shear force is going to be what? So, you can write SF at point C will be here. The equation is here. We just need to change the value of X. Okay. WL by 2 minus, here if we can calculate the length. We know at point C length is what? L by 2. So, SFC will be WL by 2 minus WL by 2, that will be 0. Okay. Next is what? Shear force at point B. You can see at point B the whole length is L. Okay. So, it will be WL by 2 minus W into L. So, we are having shear force at B, that is WL by 2 minus or negative WL by 2. So, you know the values of shear force at point A, B, C. Okay. Now, calculation of bending moment. Okay. So here we know when we are calculating bending moment, we are just doing what? Multiplying force with the distance, right? So now bending moment is going to be RA into X. This is going to be bending moment at point X, and it will be RA into X and what? And here Wx into X by 2 minus Wx into X by 2. So you know RA is what? WL by 2. WL by 2 into X minus W X square by 2. Okay. So bending moment at point A will be what? You can see the at point A, if we are finding out from left. So X value is going to be 0. Okay. Now we are calculating from left hand side. So WL by 2 into 0 minus W into 0 by 2. So bending moment at point A will be 0. Similarly, bending moment at point C. We have find out what? Here. The equation. Now we are putting the value of X in case of bending moment C and bending moment B. So, bending moment, if we are calculating bending moment at C, you can see the X value of X will be what? L by 2. Let's put that. So, here WL by 2 into at point X, it will be L by 2 minus W into L by 2 into L by 4. So, WL square by 4 minus WL square by 8. Bending moment at point C is going to be what? WL square by 1 by 4 minus 1 by 8. 1 by 8, that is WL square by 8. Okay. So bending moment at C, we have find out that is WL square by 8. Now bending moment at point B. So in case of X, we will put value X as L. Now WL by 2 into L minus WL square by 2. So bending moment at B will be also WL square by 2 minus WL square by 2. Bending moment at point will be 0. Okay. So we have bending moment at point A as 0 and bending moment at point here B also 0. If we are drawing the SFD and BMD, let's draw it. to draw the SFD. Okay. So we have shear force at point A as WL by 2. Okay, in positive sign. So here it will be WL by 2. Okay. And a shear force at C is going to be what? 0. And shear force at B is minus WL by 2. So, how to draw? Just need to draw to okay. It is the SFD, shear force diagram. Okay, we need to remember that if we are drawing the BMD of simply supported beam while application of UDL, it will be what? Parabola. Okay, the structure is going to be like a parabola. So, bending moment here. We have bending moment at A 0 and bending moment at B will be 0. Bending moment at C is WL square by 8. So, to draw here bending moment at A is equal to 0 and bending moment at B is also 0. Here it is WL square by 8 and with positive sign. So, to draw the parabola, okay, it is 0 0 and here WL square by 8. That is your bending moment diagram for simply supported beam while application of UDL. Also, if we are putting point load and UDL, the diagram will be changed. Okay. So, in our next classes, we will solve lots of another type of problems and we will learn how to draw SFD, BMD while application of different types of load in case of simply supported beam. So, to know those things, you need to stay tuned. Thank you so much.